with that. Okay, it says it's now recording, and we'll go ahead and get going. And as I mentioned before I started the recording, we had hoped to have North Carolina and ADEM involved in this discussion. We don't, and that's the purpose for doing the recording, to make this available to them at a later time. And the reason why we wanted to get together with y'all was to just begin the planning process for the green group experiment, and make sure that as we make our plans for reconstruction, which would start with milling test sections and then working on mixed designs, kind of phase one stuff in the laboratory, make sure we don't get off on a tangent that is not acceptable to the group. So that's the reason why we wanted to meet today, to begin that process.
Buzz, let me just say to Lindy, if she is on, no, she's on the computer, but there's the little sliding menu up in the upper right that you can access, and just to make sure that you don't have your mic and speakers turned off or something like that. If you're okay with us going ahead, Lindy, just type in a quick chat message there, that it's okay to go ahead.
Oh, hey, did I make it?
Yeah, there it is.
Jeez, I've been fighting with this thing.
Okay, now we got you. Good to hear from you. Well,
I'm here.
Okay. All right. Good deal. We're gonna press on then.
Oh, my computer wasn't working.
Well, just to give everybody an update, this is the sponsor projection that I presented, I believe, at the track conference here a few weeks ago, and the only thing that has changed about this is that it doesn't affect the green group study, but Florida, as a result of a meeting that we had with them on Monday, we think they have changed their commitment from the PG study, from the preservation study, to another experiment because of a pressing research need that they have. Otherwise, especially with respect to the green group experiment, I'm showing 2 X's with Alabama because it's Alabama DOT and Alabama Department of Environmental Management, with a focus on recycled tire rubber, and then North Carolina and South Carolina. Now, I've got a good update to provide that I haven't had an opportunity to talk to with Dave or with Randy, but if anyone has looked at the Pool Fund website, we're now over the project assignment level, and we've still got states a significant amount of money that's not committed yet on the website that have submitted letters of commitment, but we are past the point where the project should be assigned. And Lindy, I need to follow up with Jeff and Michelle and Kadada and figure out what the next step is, so we can begin to work to the point where we can get a letter of direction, so we can actually initiate some of the things we're going to talk about today.
All right, I'll make a note to make them aware of that.
Well, and when you talk to Jeff, if you could follow up with him, one of the states that hasn't made the commitment at the website yet is Alabama. So if you, of course, Alabama is the host state, so I think it's more of a formality than it is anything else. But if you could just remind him about that, I'd appreciate that.
I will.
And that letter of direction is important to us because we're going to start milling week after next, removing old test sections, removing sections that we placed in 2009. We're not going to engage in any activities related to the installation of new test sections, but we need to get the milling out of the way so that we can stay kind of in phase with our reconstruction contracts. We do have both the plant production and the mixed placement contracts working through the process now at Auburn. The contract documents have been released to potential bidders, and we are waiting to fill in the gaps on some of the test sections at a mandatory pre-bid meeting that's going to be held here in a couple of weeks. So that, again, kind of is a reason for the timeliness of this discussion with you guys, is we want to make sure that things are head in the direction that we expect them to head, and we got plenty of time. Now is the time to make course corrections, because we got plenty of time to do that. So essentially, for our reconstruction timeline, we'll be milling week after next, and then probably the week of the 23rd, we would like to begin doing some work and doing things related to reconstruction, Lindy, if we could get a letter of direction by that time. Of course, we won't do anything until we get a letter of direction. But
so that would be the week of April the 23rd?
Yes, ma'am.
All right.
That's right. But we can go ahead and go through the bidding and the award process, for the various different kind of subcontract type things that we do over here. We just can't spend any money until we get that letter of direction.
I understand.
Anybody have any questions about that? Okay, I'm going to keep on moving forward then. Well, as everybody has seen when we were going through the preliminary discussion process, the idea for the green group experiment really, I think, kind of was born in the group experiment from 2009, where other than the 2 high wrap content test sections, everything else that we did, well, and then the open graded surface, but there wasn't a whole lot of focus on recycled materials besides the 2 sections where we were specifically studying mixes with high wrap contents. But the idea for the green group experiment kind of came out of that. Let's have some stiff material in the middle of the structure. Let's have fatigue resistance at the bottom, and then durability and rut resistance on the surface. And let's do it with a focus on reducing the initial cost of construction, and while we do that, either hold surface performance the same while we drive down cost, or ideally make performance better. So lower initial cost of construction and as good as or better performance is really what we're trying to do by targeting this type of focus on layers that you see in this slide. Now, in the group experiment from 2009, where we had numerous sections that had all virgin materials, we're not proposing that for this green group experiment because recycled content is the state of practice to varying degrees. So we really want this to be as realistic a study as we can have, and then we would like to tie it to the previous experiments through the use of common materials, so we can always have virgin material performance to refer back to. So the recommendations, some of the basic recommendations that we're making for this is, as I said, number one, we want to try to maintain that connection to the previous study so that we can make sense of it all through multiple research cycles. And what that means is we would recommend that the subgrade and the base and sort of the basic principles of the mix designs from previous cycles, that we would use those, or the basic mix design is our starting point for the mixes the variants that we would include in this group experiment. The big difference here is the control mix that we're going to use for this green group experiment, or that we would recommend, is what I'm kind of referring to as a, quote, modernized version of our previous control mixes, so that it's not 100% virgin materials. It's more the standard type of mix that you guys would be using on all your construction projects.
Can you be a little bit more specific about that, quote, modernization?
Yes, ma'am, and I'll show you here in just a second. Another thing that we need to hammer out is our sources for the wrap and the RAS and the tires that we're going to recycle. And I had hoped that ADM would be on the line so that we could discuss the source of the tires with those guys. But what they essentially want us to do is kind of stand in the gap between industry and department, and make a recommendation that industry can embrace and the department can enable in their specifications, so that we can end up with marketable improvements for them in the use of recycled tire rubber. Now, one of the things that we don't know yet is who our contractor is going to be. And that has a big impact on the source of materials, because in 2009, the wrap that we needed to run our test mixes, we got that fractionated material from East Alabama Paving because they were our contractor, and that was material that the department here in the state would use on an interstate mix if it was a wrap mix. And if East Alabama is the successful contractor, the bidder this time that's chosen to do the work, and of course we would certainly embrace that if that's the case, but it has to be a competitive process. So we're enthusiastic supporters of that. But they've got fractionated wrap on their yard, and now they've actually got a large shingle stockpile, and they are grinding their shingle stockpile now, and they're just now getting geared up to do shingle mixes for the state of Alabama. So there's a good source of shingles on their yard that we could tap into, that if they get the contract, and if you guys decided that was the shingle source that you wanted to use. And we'll know more about, we'll know who our contractor is in just a couple of weeks. I'm just trying to more or less give you things to think about at this point in time. Now, I think that sort of the general structure that we're talking about doing, and this is obviously open for debate. This is the recommendation that I'm making, that based on discussions that I've had with Dave and with Randy about this section. But what we're talking about is a 1 1/4 inch surface on top of 2 3/4 inches of binder mix on top of 2 inches of base mix, and that gives us a total structure thickness of 6 inches. We've talked about maybe going thinner than that, but the high polymer mix is 5 3/4 inches, and it's done well because it has a super high fatigue resistance. We've had 5-inch mixes in the past, or 5-inch sections in the past, that have failed after just a couple million easels, and 7 inches now has survived 10 million easels. So we think 6 inches would be in a position in the middle there that would either ensure that we have failures within the traffic cycle, or if we're successful in extending life, maybe show some significant differences between sections if we're really good at putting these things together. Now, Randy, the reason why I'm showing 2 inches in the base layer, that's 2 inches was one of the standard thicknesses we used in 2003, but not in 2009 or 2006, I guess, in 2009. And the reason why I'm showing 2 inches in the base is because, and I kind of beefed up the binder, is because we talked about using higher percentages of recycled materials in that middle layer. So the extra thickness that we would need beyond the surface mix, I kind of threw it into the middle layer to drive the cost down as much as possible.
We need to do, well, I think this is preliminary thickness recommendations.
Yeah, I'm just putting this on the table right here.
Right. But we'll need to do some analysis of first of all, the strain tolerance of the layers, of the base layer in particular, and then what the strain would be at the bottom of the binder layer, because we don't want to create stresses at that layer or strains in that layer that are going to exceed its capacity, if you will.
Absolutely, and the reason why I'm proposing this is because our objective is to have a binder mix that reduces strains, and then have a base mix that's highly strain tolerant. And the strain reduction and the strain tolerance that we get will need to be a function of mix design and modeling that we really won't be able to do until we get permission from this group to kind of move forward in the direction that we're thinking that we want to go. So it's a.
What size stone are you going to be using in the base? You going to have 3/4 inch?
I'm sorry, what was that, Milt?
What size stone you plan to use in your base, nominal maximum size?
Well, that's up for debate. In the past, we've used 19 millimeter mixes for base layers and binder layers, but you know that's this experiment belongs to y'all. It's wide open, and we can do it the way you think we need to do it. Now, what we are proposing as a control section, and Lindy, this addresses the question that you asked earlier, is with the showing this as a surface / binder / base, kind of as a starting point to open discussion. What we've bounced around here is having our control section be a 20% dense, 20% wrap dense surface over a 30% wrap dense binder over a 30% wrap base, and we're proposing that 20-30-30 control setup in this experiment because that's kind of in the ballpark for some of the wrap percentages that states are running today. But like Milt, Milt and Lindy both, I mean, we really would like to get your feedback on this proposal for a control section for this experiment.
Yeah, we normally don't place base at 2 inches. It's usually 2.5, 3 inches, or even 4 inches.
Especially that size stone.
Yeah, that size stone. Because some of the contractors complain about dragging and all that if you got that 19 millimeter material.
And we can thicken that up because, you know, we can split the difference between the base layer and the binder layer. I stuck 2 inches in there so we could take advantage of the cost savings with a thicker binder layer, and because in the 03 experiment we had a lot of success paving 2-inch layers in that study. Everything we did was either a 2-inch layer or a 1-inch layer, and we didn't have any problems with it. And that
Were those base layers, did they have wrap in them?
they didn't have any wrap in them. No, they did not. But now the wrap that we would propose to use in this, Randy, would this be a scalped wrap or just sort of a crushed wrap or a fractionated wrap? I mean, what is your vision for that at 30%?
Yeah, I think what we need to keep in mind here is what we want to do here is what is pretty much current practice. So, you know, it's really up to Lindy and to Milt, and you know, if North Carolina gets engaged, what you guys want to do here. And if you want to use a fractionated wrap because that's kind of what the standard practice is, or if you'd rather not use fractionated wrap, those are decisions I'd like, you know, some input from the state sponsors.
Well, I'm going to tag along with Milt's comment. We wouldn't be putting down a 2-inch base layer. Our base layers generally run more than that. That being said, on the 30% wrap, our specifications currently require anything over 25% for the stockpiles to be fractionated, so that the contractor has the ability to utilize that.
Well, that being said, Lindy, do we want to? Would you want to use 30% as the control or 25% as a control and not use fractionation? I mean, it's completely up in the air, and it's for y'all to decide because it's your experiment.
We have a couple of contractors in the state that in the last year have really taken advantage of that over 25% wrap ability in our spec. And so I've got out there right now a lot of 35% because they did not pick 30. That
Right.
wasn't a common number. It was usually either 35 or 25. But a lot of 35% layers out there in the base and the binder. And I'd like to kind of see what I'm going to get
Right.
long term.
Mel,
since I've already got it out there on the road.
Okay.
Yeah, I'm okay with, 35% wrap in the base, but I'd like to see it a little bit thicker.
Okay.
Yeah, I would too. That just doesn't sit right with me.
Well, regarding the, so it sounds like we want to go 35% wrap in the base and the binder. Is that accurate? And use
That's
fraction.
what I'd like to see.
Do you want it fractionated, Lindy?
Yeah,
That suits us too. I mean, I like fractionated. You get better control.
yeah, I think so.
I can. I'm going to get this out of presentation mode and make changes as we go.
That's a good idea.
Well, it was Randy's. It was a Dave's suggestion, so I can't take credit for that. I'm going to say that. Yeah, that's a good idea.
Regarding the thickness, Buzz mentioned before that we're trying to achieve a couple things on selecting this thickness. We do want to see differentiation in performance within the cycle, and we thought that we would get that with 7 inches, and we didn't. So that's one reason we want to go thinner.
I like going thinner, but what I would do is I would rob that binder layer some and take it back to 2.5 inches and maybe make the base equal at 2.5 inches.
How about this? 2.5 and 2 1/4. I mean, if I can put 2.5 in there, but that's going to put us at 6 1/4 inches total thickness. Is that what we want to be?
Well, I mean, if 2.5 and 2 1/4 would be fine too.
Yeah,
With me.
I guess I'm okay with that.
There's one other option that
I'd rather see screens messing up. I guess maybe 2 inches of binder, maybe go thicker on the base, but you want to keep the binder at 2.5.
Well, I can set it up however you want.
No, you got that. I would rather have 2.5 on the base and 2 1/4 on the binder.
Yeah, that's what I was thinking.
What's the nominal maximum on the binder?
I would guess 19 millimeter on both of them.
but that's for y'all to tell us what you'd rather.
That's what I would do.
Yeah, that's fine.
Yeah, we are going to try to, in some of these experimental sections, try to look at economics. So if it makes sense to try to do a 1 inch, 1 inch nominal maximum aggregate size and still get the strain tolerance, if we think it's more economical, we may want to kind of throw that back out there.
Yeah. Well, I'm thinking about constructability. A lot of our contractors that complain about ride and all that, they need to have a good, intermediate layer to get a good ride.
Yep.
I guess that's what I'm coming from.
Okay.
Yeah, but everybody's okay with 1 1/4 inch surface, and that's a 9.5.
9.5 nominal.
Yeah.
And we're okay with 20% wrap there.
Yeah.
Yeah, that's good.
Well, that's your
35% wrap in the binder.
That's correct.
Okay.
And
Base and binder.
yeah,
Is
both
that okay?
in both layers. Where I think Randy, correct me if I'm wrong, but our thinking there was maybe a different design level air voids in the base to improve fatigue resistance based on laboratory testing.
Not in the control, because I don't think that that's current practice. I'd rather that layer fairly represent, kind of the current practice. So
10-4.
Most agencies aren't doing anything for that bottom layer that's different than in terms of air voids or gyrations. And correct me if I'm wrong, Milt or Lindy.
Right, it's treated the same as all the others.
Okay, well, given that then as a control section that sounds like everybody's feeling pretty good about, then the 3 test sections that we would have, or the treatment sections, those are the last 3 bullets on that list. And again, we're shooting for, excuse me, for good durability and rut resistance on the surface. And of course, we know we can get good rut resistance out of super pave mixes, but to get the most durability bang for the buck, we're proposing that these be SMAs, and the first of the three is a wrap SMA, the second one is a shingle SMA, and the third one is a ground tire rubber SMA. Then kind of going down the list for the binders, that first one is a 50% wrap binder, which we've done in the current in the 09 track. We had good success with the 50% wrap mix. That second one is 50% wrap and shingles. And then, because shingles, I think what's going to happen to DOTs is you guys are going to be under more and more growing pressure to allow both technologies. So we kind of wanted to push the envelope with it in that binder layer and have 50% wrap and shingles. And then that last bullet, the binder layer, is a high modulus ground tire rubber mix with up to 30% wrap, but not high wrap, because what we're trying to do in that last bullet is use as much ground tire rubber as possible, but in a way that that lowers the cost of construction.
Yep. Let me interject a few things here, Buzz.
Okay.
As you said, we've got experience with the 50% wrap dense graded mix, which is the first experimental mix binder layer. We haven't, we've done some wrap SMA in the lab, but we haven't ever put a wrap SMA on the test track. I know that Alabama has experience with wrap SMA.
All the time.
Yeah, it's fairly common. So that's not that kind of outside of current practice at all. Milt, are y'all doing SMA in South Carolina?
No, we just mostly do 12.5 surface course, but we're good with the SMA.
Okay. Well, we're trying to make, like Buzz said, a mix that we know is going to be durable and rut resistance on surface. The intermediate layer should be a stiff mix, a high modulus mix, and then the lower layer needs to be a strain tolerant mix. So we're just trying to engineer these mixes to achieve those primary functionalities.
Yeah. How much RAS are you talking about adding to the mix?
Yeah, that's where I was meant to go with my comment, is that we don't, that's kind of an unknown for us at this point. We've got to do some mix design work for that 50% wrap with RAS.
I would guess 5%.
Yeah, it's going to be 5% RAS. We may have to back off on the wrap a little bit. We want a high modulus mix, but we don't want to make something that's really hard to lay or anything like that. So.
Well, and by the way, to interject right here, everybody, the idea is that all of these mixes will be run as warm mix. That was our thinking. Does anyone object to us doing that?
I actually thought that was a given.
Well, I'm glad to hear you say that.
Okay, what process are we going to use on that warm mix?
It'll depend on who your contractor is, Milt, because they don't all have the same.
But for this project, I think, East Alabama will do, or I should say East Alabama, but we will save to the contractor that, if you guys want to do foaming or if you want to do additive, we need to probably put that in the contract document.
Well, and it is, Randy, the plant production contract requires any contractor who wants to bid it to have a mechanical foamer, and then it also requires a port system with an inline blender on the AC feed line. So the plant has to be equipped to give us whatever the states decide they want.
Oh, that's good.
Buzz, you looking at any kind of anti-stripping at this point? You looking at like lime or?
Well, what we did the last time, we set it up for a 0.5% LOF 6500, I think. But we also use lime when states required us to use lime. So, we may kind of come to a crossroads there because Alabama is not a lime state, but other states are. So we can run the mixes however the group decides we need to run the mixes.
Remind me, Merrill, what you guys use for anti-strip.
Well, we require lime on our higher volume mixes, the interstate types, or if we did an SMA, it would have used lime. But
okay.
And we have opened up some of our mixes to allow the liquid anti-strips. A lot of them actually.
Well, and we do testing in sort of the phase 1 part of this to make sure we don't have a stripping problem and we don't have any compatibility issues with the anti-strip we want to use.
I guess I was thinking stiffness if the lime was going to add anything to it.
It would.
But if we're not looking at it, then not an issue.
Can we talk about the percent wrap and RAS again?
Yeah.
Okay, you're talking about 50% wrap and RAS, and Lindy mentioned, keeping it a maximum of 5% RAS, which, we're in agreement to that. But I also like for us to maybe consider not having more than a 50% aged asphalt, total aged asphalt in the mix. If we're going, because if you, different wraps.
I do think that's a direction we also need to look at it from, is
because RAS has a lot of AC in it.
Okay, so do you say you want more than 50% or you want to limit it to 50%?
Limit to 50%.
See that I would recommend then we just target 50% in the design if that's going to be y'all's limit, because if I'm a contractor, I want to bid the limit to save as much money on my mix as possible.
Yeah, but I'm saying for 50% aged asphalt.
Aged binder, right? Okay. The combination from the wrap and the shingles needs to be 50% of the total binder.
Right, but no more than 5% contributed by your RAS.
Okay.
And that's kind of in line, Randy, with standard practice, right?
Well, I don't think anybody's quite getting that high at this point in time with the combination of the two, but many states do have a combined aged binder or recycled binder content, so the approach is consistent with what some agencies are doing, but the actual limit may be higher than what they're using.
Yeah. That's what our recycle spec goes on, percent aged binder. We have a maximum on that.
Okay. The base layers that you see there that are proposed, that first one is a high polymer mix with as much as 30% wrap. And Lindy, that one's in there because we've done a lot of high polymer stuff, but it's been with all virgin mixes in the past. And we think it would be very beneficial to everybody to run this mix, put it in a base layer, and do extensive fatigue testing with it in the laboratory, so we can get a handle on what happens with high polymer mix when you start putting a lot of wrap in it with age hardened binder. The one in the middle, the base in the middle is just a rich, dense graded asphalt. Can y'all still hear me?
Yeah, we're listening.
Okay, the one in the middle is just a rich, dense graded asphalt, and then the one on the bottom is an Arizona style fatigue resistant base layer, and that is
asphalt rubber.
Asphalt rubber, that's right, and it's kind of targeted at mix that's been shown in FHWA's ALF to be completely crack resistant, highly crack resistant.
Okay, so we're putting these on the very bottom to give us a balance between our stiff binders.
That's right. We're going for crack resistance on the bottom, and we're going with stiffness in the middle to give us success with these thinner buildups.
Okay. Okay.
And like Buzz was saying that.
These all look very exotic.
Yeah, and well, that's, these are supposed to be kind of a little bit cutting edge, or maybe a lot of cutting edge, but as far as bases go, they're probably exotic. A high polymer mix, we don't exactly know where we need be with the wrap content on that. We just want to make that more economical than, say, just the typical Kraton type mix that was used in their experiment in the Oklahoma repair. We want to use as much, and we haven't really decided among ourselves kind of what the strain level that we need to shoot for there. We'll look back at the data from the current experiment to kind of get an idea of the actual strain levels and try to make sure that we're making a mix or making mixes for those base layers that are more strain tolerant than our typical bases.
The last thing that well, I guess regarding the aggregate materials, you know, like we said, we're recommending that we use our sort of standard mixes that we've used here in the past in the group experiments as a starting point for these designs. So I think as a group, we would like y'all's permission to begin to investigate mix designs from that perspective, to kind of use our high wrap mixes from the last cycle and our virgin mixes from the last cycle as a starting point for these designs. Is that something that everybody would be okay with? And just to as a reminder, of course not counting the wrap, but surface mixes that we've done here in the past have been essentially 50% granite, and then the other half of the mix is a combination of limestone and sand, and then our base and our binder mixes have been essentially 50% limestone, with the other half being a combination of granite and sand. So the percentages flip-flop as a function of cost and availability and kind of targeted friction on the surface there. Milt, would you guys feel good about supporting using that as a starting point for these mix designs as well?
Yeah, that'd be fine.
The good thing about that is it kind of gives the mixes kind of broad application. You know, there's some limestone in there to address friction, but you know, granite's got a big footprint in the southeastern United States, so it tends to work out pretty well.
That's right.
Yes, sir.
I was just going to say, when you have time there, go ahead and edit that layer second from the cross section second from the bottom to be 50% page binder, and then put wrap and raz combo or something like that. That's fine.
Yep.
Yeah.
Okay.
Go back to the wearing surfaces too. You got a wrap SMA on that first one. What kind of percentage are you talking about there? Because I mean, we routinely do 20%. So I would like to see something a little bit different.
Okay. Milt.
Or do we want to just stick with the 20% there? I mean,
I'd like to push the envelope with these personally.
I also allow RAS in my SMA in my wearing surface too.
Okay. It kind of gets to the point. Do you still use polymer in that SMA when you've got wrap and RAS?
Yes, we do.
Yeah. Okay.
So that might be the thing to kind of play with, is because that is the direction that the powers that be here would like to move. They'd like to move away from the use of polymer.
Well, and that was my next question. That was the last thing about these mixes, is what kind of binders do we want to, what binder grades do we want to use for them?
Take the polymer out, that would be more economical for sure, and we'd see if it would hold up.
So we want both of these to be non-polymer.
They should do testing, so on the prettiness. I don't have any problem with it.
We want both of these to be non-polymer.
That's how I feel about it.
We can go either way.
I don't want to force anybody into anything they don't want to do.
Let's go ahead and put,
We use it all the time. We know we have good performance out of polymers, but this gives us a chance to see how it does without.
do 25. No, I'm not comfortable with 35.
Oh, yeah, not that high.
25.
Okay. Well, for both mixes,
Pushing the envelope right there.
and then 5% shingles.
Yes, because I don't think from Richard's research so far on that we need to go higher on that.
Okay.
That'd be 5%. No wrap.
What was that, Milt?
5%. Oh, you said on that second one, you got your cursor on. It's 5% raz. That has no wrap in it too.
That's right.
That's good. That's fine.
And that's what we're saying, right, guys, is that we're not going to put any wrap in that one? Or do we?
I'd rather keep them somewhat simple in terms of the
Clean.
yeah.
Well, and keep in mind with these that, of course, we're looking at kind of structural composite performance, but like the texture measurements that we'll make on these on a weekly basis, that's going to tell us a lot about surface mix quality. So it'll be kind of neat to have a 25% wrap and a 5% RAS SMA to compare to each other.
Now, on this SMA, especially this 5% RAS, are you going to eliminate the use of fibers and try to make it with just the RAS acting as the fiber?
We're gonna try that and see if it'll pass the drain down without the fibers.
Okay.
And if it will, then we won't use added fibers.
What do we want to do about binder grade? We just want to use straight, neat asphalt for the binder layers.
That's what we would here, because it costs money to bump a grade.
Yeah.
Okay.
I guess you'll be using what, a 6422?
Yeah.
Yes.
Okay, that'd be good.
Hey, we've got a thunderstorm moving in out here, so we just had a massive lightning strike. So if I lose you, you'll know what happened.
That was here during lunch. On the RAS, do we need to specify whether it's going to be post-consumer or manufactured waste, or are we just going to allow it to be the luck of the draw?
I personally recommend that we try this with post-consumer, with tear-offs.
Okay. You'll have to write that into your contract then.
Yeah. That's what we'd recommend. That's what we're using now.
There's just there's such a limited supply of manufacturing waste that's a really regional thing. I think it'd be better if we just use tear-offs.
Okay.
Yeah, just put 5% PC RAS there. Keep that.
PC?
Yeah, post-consumer.
Post-consumer.
Everybody has different terms for it, but that's what I know it means.
Okay. All right.
Lord, our acronyms. Look how long they are.
Yeah, we're gonna have trouble referring to all these mixes. Last time it was pretty easy to say, oh, it's 50% wrap warm mix. Now it's you got this and this and that and that.
We have section A, B, C, and D, Randy.
Exactly.
So I was just thinking, if somebody who doesn't know much about asphalt saw this slide, they would have no clue what is going on.
That's job security for us engineers, Merrill.
Yeah, that's what scares me is I actually understand this.
So what else about this do we need to define at this point in time so we can kind of get our bearings on a starting point?
The GTR SMA, really that last section is the objective is to meet ADIM's interest and to use as much rubber in each of those layers.
Yeah.
But to get good performance. But I think we can satisfy multiple objectives.
Milt, do you have any feelings or comments, or do y'all, South Carolina, have any feelings or comments about the quantity of GTR going into these mixes?
No, we're just now getting into that, some ourselves pretty heavy, and I think what Arizona, they use the wet process, is that correct?
Yes.
And they use what, maybe 15–70% rubber in the binder?
That's correct.
17%, I think.
Yeah, I think I read 17% somewhere.
Yeah.
Yeah, I'm good with that. What we've been doing, what limited amount we've been putting in is probably about 8 to 12. So if we could go a little bit higher and see how this turns out.
Well, that's, again, we're trying to make this mix as strain tolerant as possible there.
Yeah.
And we probably would use more like the 8 to 10% in the SMA, I'm thinking.
Our goal on that would be to match it up so that the grade of the liquid comes out to be what we would get if we had a polymerized liquid.
Okay.
And our estimates were that was around 12%.
Okay.
Don't know if that's right or not, though.
Yeah, we'd like, if we had a druthers, something around a 76-22 or something like that.
Exactly.
Okay. Well, in the Missouri experiment this past time, if I remember right, it was 11% rubber.
Yeah.
And exceeded a 76-22, but still graded as a 76.
Correct. Yes, it did.
I'm looking at these mix designs, Randy, and I'm thinking about the logistics of going through all the phase 1 work. If we could change course just a grunt and put and make like this high modulus GTR where it says less than or equal to 30%, and then the high polymer mix less than or equal to 30%. If we could make them 35%, then it might simplify the design and the batching process.
I agree.
Yeah, I agree with that too.
That's good with us.
Comparing more apples to apples, and
I think we had before, was it 30% in the control mix, binder and base?
yeah.
I think we did.
Okay.
We're just going 35% with everything.
Yeah.
Or 35 or 50%, I guess.
We'll shoot for that, yeah.
That works. On that GTR SMA wearing, just to keep your notes and everything straight, you want to put non-polymer out there by it too?
Yes.
Lindy, while I'm thinking about it, your shingle specifications, I think right now y'all limit shingles to 3%. Is that right?
Yeah, but that's fixing to change. I mean,
Okay.
I've got the draft changing that's been in the works for a while now, but we keep adding additional changes, such as taking out VMA stuff and things like that. So it just hadn't hit the street yet, but that's in play.
Okay. That was my question.
Yeah, so don't just ignore the 3 that's in there right now.
Okay. All right, how does that look to everybody?
Good with us.
And we may, as we go through this and we get results from the lab, and then we get feedback from the modeling effort and can make better predictions on the survivability of these test sections and the longevity of them, we'll need to tweak this, I'm sure, as we go, but this will give us a good starting point anyway.
Yeah.
Got to start getting our materials together and see what we can put together.
And really the last slide that I had, Milt, was just information about the Arizona rubber mix.
Okay.
So I mean, you've seen that before. I think Randy's got a meeting that needs to start at 2:30. But our goal is to get all this work done and get the fleet going before the end of August, as we did last research cycle.
Yeah.
And I think the pieces of the puzzle are falling into place now, so hopefully we'll be able to do that.
Okay.
Anybody got any other questions or comments or concerns?
Looks good to us. Could you send us that PowerPoint you got here, or post it somewhere so we can? Because I didn't take notes. Marilyn did.
Well, absolutely.
I didn't take notes.
I just sit here looking at the screen.
I took notes, but you can't read them, so it doesn't matter.
I'll send you the PowerPoint, and I'll also post the recording out there so you can go back and refer to it at a later time if you want to.
I think what you have is a good foundation to work off of. I guess you guys do your lab work and see how it's going to turn out.
All right. Well, we appreciate everybody's time. Thank y'all for participating in the meeting, and we will be in touch with you.
All right. Thanks a lot.
Sounds good.
Y'all have a good weekend.
Y'all too. Thank you very much.
Hey, Buzz?
Yes.
Hey, Buzz? Copy